The eighth question that we have is a very important and interesting question. We have been given that HCP lattice can also be represented by the above unit cell, and we have been given C is equal to 4r root over 2 by 3. We need, and the length of the diagonal of rhombus is D, and the density of magnesium is given. We need to find out the volume of unit cell, the unit cell length, the distance between nearest neighbors, and how many nearest neighbors does each atom have. So in this unit cell, so what we learn most importantly and firstly from this question is that for a particular hexagonally closed packed structure, there can be more than one unit cells also. It is depending on the way you visualize it and break it, so that to find a unit cell. We had earlier seen that a unit cell could have been, for a hexagonally closed packed structure, it could have been like this. But now we see that the hexagonally closed packed lattice can also have a unit cell like this. Now let us analyze this unit cell to find out the volume of unit cell first. Now to find out the volume of unit cell, we have been already given the density. Therefore, if we can find out the mass of the atoms present in this unit cell, we can find out the volume directly. So now let us find out what is the contribution of each atom in this unit cell. Now this atom is located at a distance d by 3 along the diagonal and c by 2 perpendicularly upwards as given. This is a rhombus of side A, and these atoms are placed on the corners of this rhombus. So in total we have 8 atoms that we have to deal with. 8 plus 1, this one, 9 atoms that we have to deal with. Now if we look at this atom, it makes this vertex, these two edges make an angle of 60 degree over here. So there will be 6 other unit cells in this very plane which will share this, and there will be 6 other unit cells above these 6 unit cells which will share this. Therefore there will be 12 unit cells sharing this atom. Therefore the contribution of this atom will be 1 by 12. Now similar goes for this atom, this atom, this atom, and this atom. Therefore there are 4 atoms which give a contribution of 1 by 12, plus these atoms, the angle here is 120 degree. Therefore 3 other unit cells in this plane, making a total of 360 degrees, share this atom, and there will be 3 other unit cells above this which will share this atom. Therefore there will be total 6 unit cells sharing this. Therefore the contribution of this one will be 1 by 6. Now there are again 4 such atoms, and the contribution of this atom, central atom, will be 1. Therefore the total contribution comes out to be equal to 2. Therefore the total contribution of the atoms in this unit cell, that is the total number of atoms in this unit cell, comes out to be equal to 2. Now therefore the total mass present in this unit cell becomes 2 into the molecular weight of magnesium, that is 24 grams, upon Na, that is 6.023 into 10 raised to 23. This gives us the mass, total mass present in this unit cell, divided by the volume will give us the density, that is 1.74 divided by the volume of the unit cells which we need to find out. Therefore the volume comes out to be equal to, volume is equal to 48 upon 1.74 into 6.023 into 10 raised to 23. Now this answer has come out in centimeters cube. Now let us solve it in angstrom. Therefore 1 centimeters is 10 raised by 8 angstrom. Therefore we can write 10 raised by 24 angstrom cube. This gets cancelled over here to give us 480 upon 1.74 into 6.023 angstrom cube, that is 45.80 angstrom cube. Therefore we get a first answer as the volume of the unit cell equal to 45.80 angstrom cube. Now let us solve the second part. Now for the second part we need to find out A. So for finding out A, we can represent the volume in terms of A. Now the volume of this unit cell will be equal to the volume area of the base into height, that is equal to C. Now the area of the base is equal to base into height. Now this is A, this is 60 degrees. Therefore, this is A sine 60 degrees. Therefore, the area of the base comes out to be equal to A into A sine 60 degrees, that is A square into root 3 by 2. We multiply this by C to get the volume, that is equal to 1.633A. Therefore, we write A cube into 1.633. This is our required volume, and we already know that this is equal to 45.80 angstrom cube. Therefore, we get 1.633 into root 3 by 2. A cube is equal to 45.80 angstrom cube. On solving this, the value of A comes out to be equal to 3.18 angstrom. So our answer for A comes out to be equal to 3.18 angstrom. A third part is we need to find out the distance between nearest neighbors. Now to find out the distance between nearest neighbors, it is very simple. It will again be equal to 3.18 angstrom, because in this hexagonally closed packed structures, these two atoms are in contact. Therefore, the distance between them will be, nearest neighbors will be equal to A, that is equal to 3.18 angstrom again. Now we need to find out how many nearest neighbors does each atom have. Now, in a hexagonally closed packed structure, again we know that for a hexagonally closed packed structure, now the hexagonally closed packed structure can also be represented like this. We need to find out how many nearest neighbors does each atom have, that is the coordination number. Now we can find out the coordination number by any atom, because it is the same for all atoms. Let us see this atom. This is joined to these 6 atoms in its own plane. It is connected to all 6 of them, and it is also tetrahedrally resting on these 3 atoms. It is resting on these 3 atoms. Therefore, it is connected to these 3 atoms also. Therefore, 6 plus 3. Now there will be another these 3 atoms on top through to which it will be connected, and therefore plus 3 again. Therefore, the coordination number of every atom will be equal to 12. That is, the number of nearest neighbors for each atom will be equal to 12. One more thing you can notice is that this unit cell is nothing else but a part of this unit cell. It is this part of unit cell that is being cut to make a unit cell again. So our final answer comes out to be equal to, the volume of the unit cell is 45.80 angstrom. The unit cell length is 3.18 angstrom. The distance between nearest neighbors is again 3.18 angstrom, and the coordination number for this unit cell is 12.